Thanks, everyone. I'm so excited to be here. So one of the hats that I wear is as a new director of SEI, working closely with Debbie, Anshu, and many of the people here. But one of the other hats I wear is as a historian of Unicode. And for that, I try to keep a little bit more critical distance. So that's the hat that I have on for this talk. So before we start with ISCII imperialism, let's start a little bit closer to home. ASCII imperialism. Has anyone heard of this concept before? Okay, a couple hands, but we know ASCII. So ASCII imperialism was the name of an essay published in 2008 by science and technology scholars Daniel Pragman and Jacob Palm. And it began with a question: why can't I use the last three letters of the Swedish alphabet on the internet? The question arose from the observation that much of the internet was still encoded in the outdated 7-bit text standard, the American Standard Code for Information Interchange, ASCII. ASCII's limited space barely accommodated the symbols commonly used in English, let alone in Swedish. Though several extensions on ASCII had emerged since its first publication in 1963, very important infrastructures like the domain name system only supported ASCII even until 2003. And the consequences of this reliance on ASCII ranged from embarrassing, like the Swedish town of Horby translating to fornication village without the umlaut, to the much more disheartening, as non-Latin script communities would have to turn to Romanization often for lack of better alternatives. So essentially, ASCII imperialism referred to the bending of non-English languages to fit the English bias that was embedded in extant computer protocols. But looking back today, ASCII imperialism is hardly an issue. So what solved the problem? The widespread adoption of the universal character code that we've been hearing a lot about, Unicode. But in some ways, we can still find remnants of ASCII imperialism today. If you look closely, you might see that the first 128 characters of the Unicode standard almost exactly match those of ASCII, a decision that Unicode founders made to help ease the transition from ASCII to Unicode. So in the history of technology, we call this phenomenon path dependence, and it refers to the locking in and persistence of certain design choices despite some other alternative being technically superior or have other advantages. So QWERTY is another example. Why do we use QWERTY? Maybe something else is better, but that's what we mostly have. So today I want to think about a different kind of path dependence in the Unicode standard that for a long time structured the digital futures of millions of internet users, that of ISCII imperialism. So ISCII imperialism is the provocation that index scripts were asked to bend to a Devanagari-centric bias in global text standards for a long time. So over the next 20 minutes, I want to provide a crash course in the history of ISCII, and I'll tell you what that is in a moment, why it might have been considered imperialist, and then what I think this history can tell us about the future of digital scripts, or scripts in digital space. So let's begin with some background. So ISCII stands for the Indian Standard Code for Information Interchange, and it's an analog to ASCII, basically. It was developed by Indian researchers in the 1980s, and it was promoted by the Indian government in the 90s, intended to represent major Indian scripts. ISCII was peculiar for its very expansive scope. So as you can see, it was a multi-script standard. You have 9 or 10 columns there, providing codes for the major writing systems of the country. The concept of a multi-script standard in itself isn't new, but what was new about ISCII is that its designers had noted, due to the common history of index scripts as descendants from the ancient Brahmi script, that there were striking commonalities across all of them. They observed that Brahmi-descended scripts were all abagidas, or alphasyllabic, meaning that the main building blocks were consonants that contained an inherent vowel. The scripts also followed a similar classification scheme and sorting order based on how the letters were articulated. To them, this implied that a common model could perhaps be developed that would allow for easy transliteration across all of the scripts. So what emerged with this was this encoding scheme that you see here. Each of the rows represents common sounds across all of the scripts, but all that changes is the visual appearance. Um, Easy enough in theory. And the idea had a notably utopian motivation behind it. India, a large, diverse, multilingual, multi-scriptural country, had a post-independence history that was marred by ethno-linguistic division. Its political leaders had long remarked that the strengthening of these linguistic identities had the potential to cause the entire country to collapse. But perhaps a unifying system like ISCII could fix that. And this was embedded in ISCII's code philosophy as well. The idea was that a Devanagari user didn't need to be able to read or write Bangla or speak Bangla to write in it. They could type their text in a Devanagari keyboard and then change the display mode. And in theory, it would render in Bangla or any other of the scripts. And this in turn could promote inter-community communication. So it's quite political. Okay, switching perspective a little bit. So back in California, in the years leading up to the first release of the Unicode standard in 1991, its designers were laboring to collect all existing major character codes, like ASCII and ISCII. The idea was to encourage adoption in Unicode by using systems that were already in place, and to achieve greater completeness, because it does take a great amount of work to create a character code. ISCII was picked up during this collection effort, quote, simply because it existed. Unicode didn't take it exactly as is. It split up the columns into different code points, because one of the design principles of Unicode is to have unique code points for every symbol. But it kept the same ordering and the same character sets. So there would be easy translations between any systems that happen to use ISCII and Unicode. And because Unicode comes with an absoluteness guarantee, it means that once something is in Unicode, it is there forever. No edits or deletions. So though ISCII may have seemed like a useful, efficient system, in practice, it was extremely controversial. Why? Foremost, it would draw criticism for seeming to privilege the Devanagari script, most commonly used to write the Hindi language, over the other scripts. Devanagari was placed in the prized first column, such that all other scripts were entered in subsequent columns and made deviations from Devanagari or from a Devanagari norm. As a result, several characters from the other scripts were conspicuously missing from early versions of the ISCII standard. For those familiar with Indian history, this prioritizing of Devanagari seemed to echo decades of Hindi supremacy across the region, though ISCII's designers would claim it was just a convenient design choice because of their familiarity with the script. Secondly, at the time of the ISCII's incorporation into Unicode, the system had barely been implemented or tested. This is a mock-up, and I don't know quite how far it went into implementation. Researchers had just begun to build a multi-script terminal using ISCII in the late 80s, and were still pushing changes into the standard in the 90s that never made it into Unicode. So a lot of people see ISCII as having been just an idea or a toy model when it got elevated and incorporated into the global Unicode standard that we still have today. So ISCII was included in the very first standard in 1991 of Unicode, but it wasn't until the early 2000s that Unicode designers really came to understand the consequences of their earlier decision when they began to be confronted with troubles in ISCII's design from a variety of user communities. So let me just highlight a few of the issues that came up in the 2000s. So one of the first challenges to ISCII came from the Bangla script community over a single letter, the letter kondatta. So kondatta was a little used letter of the Bangla script. It was essentially a silent da. So I'm going to do just a little bit of linguistics background. So like other Brahmi descended scripts, Bangla is a alpha-syllabic system where consonants carry an inherent vowel sound. So on the top left, you have ga. It's not K, but ga. Vowel modifiers can attach to a consonant to modify the vowel sound that it carries. So you have those in the red up there. And then finally, a consonant can have the vowel totally removed by a silencer, also known as a virama in Unicode, which looks like that symbol on the bottom there. So khandatta was, to some people, it seems like tha with a silencer, the same meaning. So why do we need to know all of this? Well, because when members of the Bangla user community began writing into Unicode about where khandatta was, they were met with resistance from the standards makers. To Unicoders, khandatta appeared to be a glyph variant, meaning only a different visual representation of that silenced tha. So instead of using tha with a hollant, you could put in this graphical flourish, and according to Unicode's design principles, that meant you only included characters and not glyphs. Khandatta didn't need a unique representation. But from the Bengali perspective, this was a gross mischaracterization. While historically, khandatta had begun as a cursive flourish, over time it had taken on its own status as a letter of the Bangla script. Every child would see this letter with its own spot on an alphabet chart that they would see in school. But conveying this intuition to standards makers across the world proved difficult. Over 4 years, appeals would come in, becoming increasingly furious and frustrated over khandatta's representation in Unicode. Initially, Unicode provided a code point sequence, kind of a short recipe for representing the symbol in it, and it conveyed this on its FAQ page on the website. And it made use of other important characters in our stories as widges and swinges, 0 with joiners and 0 with non-joiners, and the virama. Somehow the situation became even muddier in this process when an Indian expert accidentally conflated Devanagari with Bangla and said that the halant forms, or the silenced forms, in Bangla could be analogized to the half forms in Devanagari. So something that could be interpreted as offensive to others. This led to glitches in text where vowel modifiers could suddenly attach to khandatta, like at the bottom there, something that's linguistically illegal. Eventually, Bangla script experts were able to articulate arguments that showed that khandatta and tha were semantically distinct, meaning that if you used one versus the other, the meaning of the words would change. So there are 2 examples there. And this was enough to prove that both representations needed a distinct status as code points in Unicode. But why was this process so difficult, and what did it have to do with ISCII? So let's return to ISCII's original code chart. In lining up the characters with Devanagari, certain script-specific idiosyncrasies got left out, like Bangla's khandatta. And though these symbols were added in later versions of ISCII, they never made it into Unicode, and thus led to these long debates that might not have happened otherwise. Secondly, there is a philosophical slippage between ISCII and Unicode. ISCII's designers believed that their standard followed a phonetic model, just sounds, instead of the graphemic model of Unicode. So khandatta wasn't a unique sound in their view, and they had imagined second-layer technologies that were never invented to be handling these types of issues. In Unicode, what happened is that all of these control characters came into play to deal with all of these idiosyncrasies. But these unwieldy sequences were often error-prone in practice, producing mistakes like the vowel modifier appearing on the khandatta, or just not providing enough ways to represent the whole swath of character distinctions that were needed. Users often found this maddening. Not only were they inconvenienced and their text glitchy, such missteps evoked latent resentments and avocations that the language politics of the subcontinent were again playing out in the digital arena. The bugs around khandatta were seen by some as nothing less than a slight against the Bangla language, and correcting it was necessary to preserving the future of Bangla in the digital age, just as in the same way as freedom fighters fought to preserve Bangla in the Liberation War of 1971. I'm going to zoom through a couple more examples. So after the issue with Kondotho was resolved, Unicode members started to see stirrings around many other script-specific letters mishandled by ISCII. So the next big challenge came from the Malayalam user community, which had its own class of silenced consonants called chilus. And this was not just one idiosyncrasy, but 6. In this case, the scene played out differently. Though Bangla users came to be generally unified in their position for Kandata, they tended to agree after 4 years of debate, the Malayalam community showed greater discordance. Some advocated strongly for unique Chilu code points, showing misspelling arguments similar to what the Bangla experts did. But others pushed back, saying Chilus were a recent invention of the 20th century, a type of typewriter reform, and should, in a sense, be turned back. Unicode found itself in the middle of regional script politics as state and national level government officials took different sides in this debate. I don't think Mark Davis is here today, but he got a lot of mail during this period. In the end, Unicode decided to follow the same path that it did for Kondata and encoded the separate characters. In this case, their initiative proved unsuccessful. When they did a review 6 years later, they found that almost no one was using those new code points. The Malayalam community had rejected their proposal. And they had even said that they don't mind the comparison to Devanagari. There is nothing wrong with ISCII in their view, and ISCII should be accepted. But the comparisons to Devanagari were not equally accepted by other language groups. And I'll finish with one very contentious example from the Tamil user community. In this case, at stake here was not just a handful of characters, but the entire encoding design for the script. The Tamil language and script are distinct from others in North India in many significant ways. Though the Tamil script shares a common historical background, being a descendant of the Brahmi script, the language is part of the southern Dravidian language family instead of the Indo-Aryan language family of northern India. In particular, Tamil doesn't have consonant combinations or conjuncts, which are one of the most difficult aspects of encoding Indic scripts. Dealing with conjuncts is part of what gives Indic scripts, along with Arabic, a distinct designation within the software internationalization industry of being called complex scripts. Complex scripts are those where the visual form of the character varies depending on the context. So Arabic characters will have initial, medial, final representations. Indic scripts change in many different ways depending on what letter is next to them. And they require sophisticated text processing to appear correctly on the screen. The issue that the Tamil user community brought to Unicode was around this classification as a complex script. To them, it felt as if Tamil had been unfairly grouped into this category when it really didn't need to be. Tamil had a very clearly bounded set of characters, exactly 247, in contrast to the amorphous set of hundreds that other Indic scripts needed. By being grouped into this category, which was rife with zwidges and swinges and grammars, Tamil support was being unfairly delayed in important software applications like Adobe Photoshop or InDesign, which many in the community wanted to use. The Tamil user community was significantly organized and motivated around this argument. For one, they had a strong sense of identity and pride, having been one of the strongest proponents against making Hindi a national language in the decades after Indian independence. They were also remarkably self-organized on the internet from an early stage, organizing conferences from the 90s and building their own keyboards and coding standards and applications through the 2010s in a group called INFIT. So INFIT approached Unicode in the mid-2000s, demanding that a whole new Tamil encoding be added to the standard, which they had already spent years testing and approving. And they wanted to be pulled out entirely from the ISCII model. They had their set of characters that should be added as a new code block. And in this case, ISCII was being actively contested. In their view, the Unicode Indic block was, quote, built on an enormous, complex, error-prone edifice based on an encoding that is not built to last. In this case, Unicode would not relent. Though the Tamil community was correct, it would be more efficient in a way to have their script encoded separately. Doing so would go against Unicode's principles. So an entirely new redundant block could not be reasonably added, but appeasement measures were put in place, such as mapping between the code points that the Tamil community had come up with and the existing Unicode standard. But many users were still unsatisfied, leading to fierce debates within the Tamil community and shouting matches with Unicode deep into the 2010s. To Unicode observers, it seemed as if there were two familiar camps of critique: the technical advocates who had found practical issues with Unicode encoding and could be satisfied over time, and the cultural advocates for whom Unicode and ISCII symbolized an unjust, domineering force that needed to be resisted. So, what is ISCII imperialism? In one sense, it refers to a very niche set of technical troubles, essentially Unicode's overuse and abuse of control characters, these widges and swinges and brahmas, that were increasingly applied to handle the idiosyncrasies and the breadth of index scripts that seem to stem from ISCII. For user communities, ISCII imperialism also represented the antagonisms of regional language politics that were being read into the motivations and outcomes around INDIC encodings. And then finally, it was something of a mentality. Within the minds of Unicode members, it was a firmly held belief at first of ISCII's integrity that did give way over time through cases like the ones we've been talking about. As some representatives reflected to me on the shortcomings of ISCII, quote, "We were a little naive. It's taken time to figure out if we could do it all over again, we might do these index scripts in significantly different ways." Now the philosophy had changed. You take the writing system and you analyze it on its own terms. You don't just assume that the Devanagari model is going to work. The assessment is if you're going to have to put in a lot of joiners and non-joiners, it's just more trouble than it's worth. Though a strict adherence to ISCII led to a troublesome pathway to digitization at first, I think the years after paint a more promising picture of receptiveness to change and willingness to patch and adapt the model. Though ISCII is still with us today, those code points still exist, I would say it's a more beaten on and bandaged artifact. It's no longer sacred, but it's even fodder for criticism amongst its previous advocates. So I'll just close by asking, in your view, is ISCII still with us? ISCII imperialism still with us today? I'll quote Pargman and Palm and say, the title of this talk was chosen for me just to provoke and command attention. So thank you.